Good day, everyone. That's the universal form instead of good morning, good afternoon, good evening. My name is Vince Cerf. I'm Vice President and Chief Internet Evangelist at Google, but for purposes of today's webinar, I am a member of the board of the Interplanetary Networking Special Interest Group, and you've just joined a part of our Academy discussions, and today it is the topic is interplanetary internet governance. I have with me Dr. Scott Pace, who's director of the Space Policy Institute and a professor of practice of international affairs at George Washington University's Elliott School of International Affairs. And I suppose, Scott, if our work goes well, that will be the School of Interplanetary Affairs at some point, or you'll be able to set off a new evolution at the school. Ladies and gentlemen, I am not going to try to read all of the wonderful history behind Scott Pace's contributions, but I will say that he was executive director of the National Space Council, who reports to the Vice President of the United States. I had met him well before he undertook that role, but it was a vital role in the story of space policy here in the United States, and so we owe him a debt of gratitude, not only for his work in the Obama administration, but also for his contributions to the architecture and policy panel, the AWG of the Interplanetary Networking Special Interest Group. Scott is touching on topics that are going to be increasingly important to all of us as we watch this unfolding of commercialization of space and the engagement of multiple parties, multiple stakeholders in the implementation of products and services that are operating well outside of Earth's near-Earth envelope. So, as they often say, without further ado, let me turn the microphone over to Scott Pace. Scott, the floor is yours.
Super, Ben, thank you very much. One correction I'll make, the Obama administration probably doesn't want to admit to any contribution I made, say for the Bush and Trump administrations did. But the good thing is space is relatively nonpartisan or bipartisan. And so a number of things that were done in the Trump administration with me working for Vice President Mike Pence have actually continued under the Biden administration, and so a good friend of mine is now the current executive secretary, and I wish him all well. So one of the few areas I think of collegiality in Washington in this space regime. Also, maybe not mentioned to give people a sense of my biases, I did about 10 years working with the ITU in supporting some things during the end of the Clinton administration, actually, and then into Bush administration, dealing with allocation of space spectrum for GPS. And so that is what got me exposed to international governance issues within the International Telecom Union. So can cover some of that. So the first thing, as many of the people tuning in will know, is the interplanetary internet. It's going to be familiar, you hope, be able to use email applications and other things on it, but it's going to be very different. And the wonderful analogy, which I stole from someone else in the group, is you can think of the terrestrial internet is like traveling from LA to San Diego. You get on the freeway, you drive, you get off, get your termination point, and all good. And this terrestrial internet is one where it was a government program for sharing computational resources that then transited into what is today a multi-stakeholder enterprise, not just governments, but lots of other people involved in it. And given how fast it grew, kind of technology came first and governance questions came a bit later. And there are still arguments over this and over the vision of the internet. The interplanetary internet might be likened to traveling from LA to Jakarta. You get in your car and you go to the airport. You catch a ride. We call it maybe bundled protocol airways. and you get to your destination. You then get off and drive around, and you may have to change planes. You may have to wait for the flight. You have to have a lot of things have to literally line up before you can do this. So it's a bit more complicated. So, but familiar but different. Space communications today, Deep Space Network in particular, are point-to-point, governed by national space agencies and various cooperative agreements among them. And there's a number of complex processes that assign spectrum and time and what's going to go on over these point-to-point enterprises. Much of it is, in fact, automated, but some of it is really judgment calls about what's important and what's not. Barriers to entry are somewhat high than the regular internet, but there's also opportunity to take some lessons learned from the growth of the internet, where governance issues weren't really dealt with until people realized what a big thing they had. So I think one of the bottom line up front, to me, as again probably the most non-technical person on this call, is that internet protocol issues of various sorts are probably the most really immediate thing I think for the community to think about as it impacts governance. Right now, of course, IP is being used. It's certainly on the early Artemis landing programs. I think SpaceX is using IP version 6, but maybe not a lot of it. And there needs to be some sort of transition strategy for implementing DTN and bundled protocols that can cope with delays and communication breakups, which are, going to happen in space. And it's entirely possible, again, the implication of this is that you'll have pretty independent internets that will arise on other moons and planets and spacecraft navigating the solar system. This could easily go bad, a bunch of things that don't really communicate with each other. It can go bad if you try to extend IP protocols to areas where they really can't scale and go. And one of the issues needed is how to disjunct Earth uses of IP addresses for any uses off Earth. There might be IP address use, say, in the local lunar base, or maybe between a rover and a lunar base. But once you start getting away from, I think, relatively local areas, BP is going to be necessary. And how do you make sure you don't confuse yourself between what's happening on the moon versus what's happening on Earth or other systems? Same sort of disjunction needs to happen for the autonomous system number and numbering space. And one of my naive questions is, do we make that some topological thing like the moon or some distance from the moon or measured by light time distances? I don't know, but certainly where people want to draw boundaries for ASN numbering space is going to be a subject for debate. Now, in the near term also, this numbering and domain name structure is going to be needed for future expansion and scaling. Again, you can get away with it for right now for the existing Artemis missions, and certainly we're doing this only in a limited number of ways with existing robotic missions. But there's an old French proverb that goes, "Nothing lasts like the temporary." And something that might be temporary seemingly could easily go on for quite some time with a number of dysfunctions as a result. So how the authorities and sub-authorities for numbering are managed, national level, agency level, program, project level, is something that I think the internet community should be discussing. And whether or not there needs to be a defined relationship between IP addresses, node numbers, domain names. Certainly domain names are critical for electronic mail and World Wide Web, but it's an open question about how quickly there's going to be transition to use of the bundle protocol, and then how the references between the internet, as we know it today, internets plural, and an interplanetary internet should work. So it's like familiar problems, but somewhat on steroids. Now, among the things you want to nail down first, if you're looking at the software stack, do you have wire or 802.11b? What are you talking over? First thing is you got to have spectrum. If you're in space and you don't have spectrum, you don't really have anything except maybe a local wired Wi-Fi system on the moon. The good news is the U.S. has put forward a proposal for a new agenda item to be discussed at the next World Radio Communications Conference, which will be in Dubai of this year. And the thing is fairly long, so I only just did a screenshot of the beginning of the proposal of a draft new resolution that says, considering people are going to be using and the scientific and commercial operations are on the moon, around Earth are increasing, and through the next few decades, we're going to need to have some understanding of what spectrum we're going to be used there. So a first discussion of lunar operation in both space-to-space service allocation as well as Earth-to-space, space-to-Earth are going to go on. There is no moon service allocation yet. If you ask about communication link between, say, the lunar surface and a spacecraft, they say the gateway or something coming toward the moon, that's all space-to-space. ITU originally developed for telegraphy. It later evolved to handle wireless. It later evolved to handle satellite systems. And right now, the only kinds of allocations are space to ground, ground to space, and space to space. Clearly, as we start operating on other planetary surfaces, that seems rather limited to call everything off Earth space to space. So that will evolve, and this kind of resolution is maybe the first step toward thinking about how that might apply. And there's a number of specific frequencies in the resolution that are being talked about. So after naming and numbering and spectrum allocations, decisions are needed on standards. And I think, again, everybody here probably understands the importance of standards. Where the domain name boundaries will be, and can you get international agreement on that? There's been some recent press stories about ESA talking about there being a lunar time zone. And without debating the merits of that, that's an example of a particular domain getting a name and then saying how far does that go and what would be covered in a lunar time zone. And there's a variety of ways one could tie it to characteristic gravitational sphere of influence, transmission times, maybe some topological connectivity like sharing a common contact graph. I don't know, but that's, again, what we're looking to the technical community to suggest. Another one is adoption of a coordinate system for operations across the physical domains. The good news there is that seems to be largely settled. A baryocentric celestial reference frame, BCS, is what's used for spacecraft all through the solar system. Don't see any reason why that would change. Requirements for time standards, not just time zones, but what are the time standards and how you would distribute precision time for the functioning of that network. So relativistic corrections, both special and general, are needed, and determining what standard you have to meet for, say, a DTN bundled protocol network to function properly. The political side of this is things like, what is a time standard? Every time standard on Earth is tied to a national lab of some sort. So in France, it's BIPM. In the US, it's the US Naval Observatory. We talk about UTC Moscow time and so forth. I once tried to suggest use of GPS as a UTC space time, and I'm still pulling the arrows out of my back for that transgression. But some sort of space time, maybe around the moon, maybe with local clocks, will wind up coming up. But before we get to that definition, the definition of time standards and how you distribute precision time to what level will also be needed. We know how to do this. This is not a technical problem, but getting agreement to do it is something still to be done. As I said here on the chart, time transfer is largely a solved problem on Earth. For interplanetary internet, it's complicated. I know people working on the Europa program fairly far out, maybe spend half their time, one of their specialists spends half their time worrying about this. And we'll also need to correct for computer and spacecraft clock drifts. So what are the standards of the clocks? Is everything going to be, a cesium level clock, or will there be lesser clocks that will be allowed? For the internet, again, this crowd certainly knows about network time protocols and correcting that to UTC time. Should there be a space version of that? And you can have an argument, a cost risk trade, because no one answer for implementing a space NTP is whether you would trust a single clock or the moon or Mars, or whether you should have an ensemble of clocks to maybe take out local gravitational effects or maybe systemic biases that might occur. Certainly on Earth, we use multiple clocks around the world to develop UTC. And as I said, mentioned down on the bottom, there's a political aspect of using terrestrial ATC laboratories. Could we create a UTC moon or Mars that would, again, be recognized by anybody? Okay, we have a couple of ways of talking about this outside of the regular internet and time communities that, again, people are familiar with. As of March today, there are 23 signatories of something called the Artemis Accords, which is for countries that have expressed an interest in participating in Artemis and agree to follow international law and as it applies in and around the moon. There are a couple of notable exceptions to that. For different reasons, Germany, India, Russia, and China have not signed up or expressed an intention to sign up. In the case of Germany and India, it's more a disagreement over using the accords as a mechanism for agreement as opposed to a binding international treaty or amending the current international law like the Outer Space Treaty. In the case of Russia and China, it's more political on their part. For the record, there is nothing that says they can't sign. In fact, if they wanted to sign tomorrow and commit themselves to it, no country, including the United States, could really object to that. Section 5 of the Accords is probably the one that's most relevant as it calls to this conversation. It calls for interoperability across all participatory signatures. They want to have interoperable and common exploration infrastructure. And they cite some examples like fuel storage and delivery and landing structures, communication systems in particular, that will enhance exploration and utilization. And the signatories commit to using reasonable efforts to utilize current interoperability standards and to establish such new standards when current standards do not exist or inadequate. So what I was saying about standards and naming protocols and so forth, I think falls quite within the intent of Section 5 here of the Artemis Accords. Now, so much of the frustration of the State Department, NASA currently does not have one set of definitions as to what constitutes cislunar space. More than one Foreign Service officer has wanted to put a definition in and has not been able to get anybody to agree as to what that means. Now, we have a defined space service volume for global navigation satellites services, so receiving GPS out through GEO and even out to the moon. We have defined power levels and volumes to be serviced, but it's not really tied to the cislunar term. And so again, the relationship of interplanetary internet to domains and physical domains is going to be a discussion, I think, certainly among the Accord signatories at a minimum. And the near-term issue, of course, is the NASA LunarNet program that will be involving a number of space agencies that are Accord signatories. So precedents are going to be set pretty much in the near term that will then shape how stuff will later occur. And I'm looking at, again, definitions. There'll be the need to communicate into areas that are going to be problematic, like shadowed craters or underground tunnels that are not directly accessible. So relay stations, beacon systems, all of that. It's not just one giant Wi-Fi field. It's going to be a whole bunch of different systems, depending on the physical area of operation. So I've mentioned the UN, a couple of times here, and just to be painful, I thought I would show all the different organizations that can get involved, and which ones you need to care about and which ones you can probably kind of ignore. In the UN, there's the UN General Assembly, which is all the countries, roughly 193 of them. There's a conference on disarmament that deals with anything relating to space weapons, arms control, and so forth. The ITU, which I was just briefly mentioning. Reporting to the General Assembly is there's a UN First Committee and Fourth Committees. First Committee deals with disarmament and security issues. The Fourth Committee deals with sort of special issues. Interestingly enough, space reports to the Fourth Committee, civilian space. which is supposed to deal with decolonialization. So we have to make sure we don't talk about space colonies, because the whole point of the fourth committee is decolonialization. There's then conversations back and forth between first and fourth committees about dual use technologies like launch vehicles, remote sensing, maybe communications. Currently, there's something called an open-ended working group, which means it doesn't have a set deadline, that is discussing space security issues and reporting to first committee. The area that I spend more time in is Committee on Peaceful Uses of Outer Space, which is all civilian, but some dual use. So this committee will develop things like orbital debris mitigation standards that it then accepts. Actually, it really recognizes standards that others have developed and have then brought into the committee. The committee, I don't think, is terribly great at doing original technical work, but it is good at taking work from technical experts, massaging it into an international consensus that people can then refer to. There are two subcommittees under COPUS. The legal committee, dealing with things like where does space begin, or applications of international law. And the one that is a lot more busy is the scientific and technical subcommittee, again, where discussions of satellite servicing, remote sensing, nuclear power sources, and I would suspect interplanetary internet would be reported out, progress or whatever would be reported out through the STSC. The committee operates by consensus. So if you don't have a consensus, you don't have an agreement. I've found that that's been very helpful for protecting U.S. interests. It makes things harder to get done. But on the other hand, it means kind of dumb things have a harder time happening because of that consensus principle. Because it's an international multilateral organization, you do get official positions. You get people paying attention when they show up. But because it's not really a technical organization, they really depend on outside groups, whether orbital debris or internet, to come up with technical consensus and then bring it into the organization to then be blessed and worked on. Going back to the ITU, there is a fairly complex process of regional positions. The US is part of the Americas, Europe, and then Asia, big regional groupings. And then there are technical groups that focus on specific topics like space services or terrestrial mobile. And what happens is the regional groups build up their positions, the technical groups build up their positions, and then they come together and blend at World Radio Conferences, which are treaty-making bodies that then amend the ITU convention. So there's a couple different balls to keep in the air. ITU in general is not going to hopefully get down into internet protocol issues. They have tried in the past, and the event has the scars of trying to get into governing the internet from the UN. That hasn't gone, hasn't succeeded. But what has happened is countries like China and Russia have pretty much gone their own way. The Great Firewall of China, Russia has its own system. So you can certainly imagine pardon the phrase, balkanization of internets globally before everything is said and done. And then finally, you have pretty pictures. You can see the picture in the center is of Geneva, and the one on the right is of the UN offices in Vienna, and New York is kind of the most brutal architecture. It's not terribly attractive. Others are more better looking. So talking about COPUS, like the UN Internet Governance Forum, as I've stressed, it's not really an effective forum for technical development operations, but it is a great forum for information exchange. There is a group called the International Coordination Committee, ICG, on GNSS. So all the GNSS providers, GPS, BEDO, GLONASS, QZSS, so forth, all come to the meeting for information exchange. They represent official position of nation states, and it's a way to improve transparency and coordination without anybody ceding national authority. Something like that, an ICG for lunar operations, you can imagine coming up, not just for interplanetary communications, but for also things like what guard frequencies are people on, what's the size of a landing pad area for safety reasons. So stay tuned for if COPUS gets around to forming a International Coordination Group for Information Exchange. We have other forums where space agencies talk to each other. So LunaNet right now is covered, but we don't really have one that deals at a multilateral nation state level. And since it's difficult for the US folks to talk directly with China, multilateral places are, I think, probably among the more promising areas for information exchange, given limitations on bilateral US-China discussions. Now, COPUS has been spending time developing guidelines, for example, like the end-of-life disposal of orbital assets. Two areas that I would suggest for monitoring. One is the proposal to create a radio frequency quiet zone on the lunar far side. And this could be implemented a number of different ways through the ITU or the Consultative Committee on Space Data Standards. I know there's a number of people in the ITU who would like to auction off radio astronomy spectrum, use the proceeds to buy a lunar base, and send all the radio astronomers to the far side of the moon. But before that happens, there will be probably operational limitations in and around the far side of the moon that will make communications more difficult or challenging on far side. Another one is the provision of space safety services. There was an international treaty, 1968, on the rescue and return of astronauts, and it imposes a positive obligation on member states to treat astronauts as envoys of mankind and provide aid if they're in distress. So a solar system internet that supports emergency communications, regardless of nationality, could be an example of how Artemis Accord members or whoever is cooperating in solar system internet is fulfilling their obligations under the treaty. So there's a safety imperative that is there, and it's not. People are talking about it, but it's not really fully recognized yet because they don't quite see how it might be implemented. But as solar system internet becomes more real to people, then I think you'll see that safety function get more attention. So some observations. The good news is, from the standpoint of a political or a policy guy, there's no real fundamental governance barriers to creating an interplanetary internet. You don't need a positive authorization to make this happen. Multiple forums already exist to explain and promote the concept, ranging again from the ITU and Artemis Accord signatories, UN COPUS. There's no centralized authority to really deal with, but really a lot of complex technical standards, interfaces, and protocols that have to be tended to and implemented. And the old joke in Washington is a point of view is worth 50 IQ points. If you have a point of view that you can get technical consensus on, it doesn't have to be 100%, but enough to implement, that will go a long way. The political and policy community does not want to hear people arguing about standards that they know nothing about. They'll just tune you out and say, come back when you're ready. So if you want to make more rapid progress, driving toward a technical consensus that does not have to be politically adjudicated would be important. Consultative Committee on Space Data Standards is working on a number of standards relative to interplanetary internet. Some of this work may or may not overlap with other standards bodies, of course, IETF, IOAG. Question mark about ITU T sector. What I was talking about on spectrum earlier is ITU R sector, which allocates radio frequency sector. T would deal with things like time standards. I think you want to be careful about letting them sort of get into this. I think the space people want to settle what their timing needs are and what the implications of different architectural approaches are. Once that's done, getting that locked down into an ITU standard can be fine, but it can be a dangerous place to develop new standards. A few years ago, there were efforts to have multiple different time standards that were disjunct from national laboratories. And there were people in the high-speed trading community and finance that were very interested in that, because if you could have a standard that was legally recognized and you could shave a few milliseconds on a high-speed trading network, you could make a lot of money. So a lot of mischief in things like that. So you want to make sure your technical community is together first. Again, as a non-technical guy, just reporting what I hear, interplanetary internet cannot be based on IP, but must use DTN-BP. I can see it being used in a very localized system. The pacing challenge is going to be determining time to include special and general relativistic corrections as a technical issue. But please, no one should think that internet in space is just going to be an extension of IP. The spectrum for lunar common nav needs to be recognized internationally. That will in turn affect the kind of amount of bandwidth you have, which will in turn affect the efficiency of your communications. So some of the complicated scheduling processes that we go through now on Deep Space Network are still going to be around. I don't think they're going to go away completely, but the boundary conditions we're going to work with. What's the amount of information we can shove through the pipe at any time? Of course, Shannon's law tell you it depends on the bandwidth and the power you got. Power we might be able to get, but bandwidth we may not be able to get. So the outcome of those spectrum discussions will set major sets of constraints. And as I said, the U.S. at least is raising this as a specific agenda item. I trust that NASA is already talking to the Space Frequency Coordination Group, which supports ITU, to make sure at least the other space agencies are on board with this. And that could include Russia and China. They don't have to be Artemis Accord signatories, but anybody operating in and around the moon, we want to get on the same page. I close with talking about the way ahead. As I said, no fundamental barriers. We need support at the ITU and timing. And then how do we get agreement? And I would look to you all to tell me how to get to agreement on a naming and numbering scheme and make sure that we don't let legacy standards go on for any more length than they have to, because that will constrain us all. I wanted to throw in two charts that are not mine at the end, but Laura Donardis gave a great talk, I think, in a recent meeting where she talked about, from her perspective, insights on space governance from the experience of terrestrial internet governance. And the red arrows are my additions, where I wanted to foot stomp her observations, the common numbering scheme, and then interoperable, the classical internet. But interoperability can take on a lot of different forms. And I think the cleaner the break between the two, you might have classical internet operating, again, on the moon in local areas, but intermixing BP and IP seems like a recipe for badness. And then finally, a framework for multi-stakeholder internet governance. And she points out some differences about resources were implemented, how standards were done. Probably the biggest immediate politically relevant decision is this going to be driven by governments, or is this going to be a multi-stakeholder approach as the internet itself was? The internet going as a multi-stakeholder approach is probably the most salient political reality for it, and it's a very different world if it's only governments in charge. I think the same is true for solar system internet. The good news, I think, among NASA and other space agencies are leaving the door open to moving beyond a government-only system. So that's good, but one can expect there may be other countries who will not take such a evolved attitude, and will be important to minimize damage and make sure we continue the multi-stakeholder approach in space that I think has worked so well to date on Earth. With that, I turn it back to Ben.
Fumbling around finding my unmute button. Wow, I can't believe that you actually did that in 30 minutes. I mean, that is truly phenomenal, and what a giant collection of challenges that you put in front of us. We have a number of questions that I think we should get to, and then we can talk a little bit about what comes after this particular webinar. But what I think I'm going to do is hold these slides. I wonder if you can actually stop sharing while we have our Q&A period, and then we'll pull the slides back up so I can do a little wrap up. We already have several questions in the Q&A box, and so I thought, why don't we begin with that? Oscar Garcia asks, what are the forums where time in space is discussed? And you touched on that a little, so I don't know whether you need to amplify on that.
Well, technically, all time standards can be discussed, in the ITU. But I think the space folks need to get an answer for themselves together first. So the first place I would look to discussing this is within the Space Frequency Coordination Group among the major space agencies, and particularly the people working on LunaNet. I don't know that and again, there's a bunch of media reactions are going on just actually today as we speak about this idea of a time zone for the moon, because that's gotten people kind of excited. But the first thing really is a technical question about how precise do we need time to be for LunaNet to work, and how do we do time transfer to get that system to work, and then what are the ongoing sustaining aspects of it. So I think it's going to start inside of LunaNet within the space agencies. And then it will likely expand into CCSDS. And I would suggest not going to ITU-T sector until everybody is really settled and we're ready to have something that commercial, academic, industry people can go look at more broadly. I think we have to get our own house in order first before trying to solve things at the ITU level.
Well, not to put any words in your mouth, but I would render that as do not ask questions to which you don't already have the answer.
I think their phrase is ask me no questions, I'll tell you no lies.
Or something like that, right? Yeah. So there's still a lot to be done in that space. Jorge Emodios asks, being the ITU is so involved, how is the private industry going to have a seat at the table? This gets to your multi-stakeholder point. And that raises an interesting question about ITU's slow, I would say, recognition that multi-stakeholder processes may actually be in its interest. Mm-hmm. Bogdan running the ITU now, perhaps she has a positive view of that. And certainly the Internet Governance Forum, which is not sponsored by the ITU, but sponsored by UN, and is an adjacent organization. Everything is very multi-stakeholder. So how do we respond to Jorge on that one?
So the first sort of good news is that private industry can participate right now as a sector member. I mean, major corporations pay to be sector members, and that doesn't mean they don't get voting rights, but they get to show up, participate in debates, do information papers and all of that. And in the internet world, it was attempts by Russia and China to limit the participation, I think, of sector members, which was a problem. So the ITU actually is pretty open to that. When U.S. delegations go over, they typically have people from government agencies, but also they have private sector folks on board. And for example, I've done both. I've been both a private sector person on a U.S. delegation. I've also been a government person on a U.S. delegation, and you will certainly see other countries that have private people on their delegations. The U.S. tends to do it the most, but it's by no means, really forbidden. The main thing about ITU is that it's rather opaque to outsiders who are not on the Del. So this is not something where there's a lot of press coverage. They don't accredit a lot of press. So deals are made for billions of dollars in whole industries in secret in Geneva. One nation, one vote, no Security Council, no veto override. They play for big stakes. They take a long time, but the thing that's really interesting about it is you see where the industry people think the technology is going to be in, say, 5 or 6 years. So I was there when we were debating 2G and this new thing called 3G, and what would 4G be, and things like that. So as an early warning system, it's definitely interesting. But you first have to convince a national delegation to take up your cause. And if you don't, you can still participate kind of on your own, but you don't swing a big bat unless you have votes, and votes are with the national delegations. So Jorge, I would say, being a sector member, which is, I forget what the current numbers are. It used to be like 20 to 30,000 Swiss francs a year. It wasn't cheap. but it was certainly doable. And you had to be tied to an organization. You couldn't participate as just random individual. You had to be some organization, but that included NGOs. So it wasn't that restrictive. I see a question from Oscar again. The interests and goals of each of the different countries in space exploration. I teach a 2-semester course that topic, so I think that maybe too broad. Each country has its own interests. Some people like to be in the space club. It's a sign of an advanced, developed country. There are ways that countries. One of the things that's good about the moon, and where solar system internet can help, is it provides a potential on-ramp for countries that previously weren't able to participate. Space used to be something that really only the US and the Soviet Union did, and then it expanded to Europe and Japan. Now, with the growth of the commercial space industry, many developing countries are able to participate. One of my favorite examples bring out is Astrobotic, is a lunar delivery kind of company. For $1.2 million, they'll put a kilogram for you on the lunar surface. So the Mexican Space Agency bought a payload, and they involved students and a small rover and all that. So Mexico will be the first country from Latin America to put a payload on the moon, and they do it as a result of partnership, of course, with the U.S. company. And so the moon has got a lot of different price points. Mars is really hard. Mars is a different category. But because the moon has a lot of these different levels to it, you can do really major things, and you can do fairly modest things. But as long as you can communicate and get a ride, you can participate. And so to the extent that Solar System Internet lives up, I think, to its vision, it will be yet another platform for the democratization and globalization of space, which has really been the major trend since the end of the Cold War.
So it's Vint again, and it turns out that I briefly was dropped off the call, and when I came back again, all the chat disappeared. So everything that was asked in there is no longer visible to me. But I did catch 2 things from Jim Shear, and I wanted to ask him to amplify on that. He mentioned that there were activities underway already to deal with the coordinate system and with timing. So I wonder if Jim, if he's on the call, maybe he could just say a little bit more about that for everybody. Are you on the call still, Jim? There he is. Oh, but maybe he's not listening. Well, okay. In that case,
unmute. He unmuted.
Can you hear me now?
Yeah.
Yes, we can. Now we can.
Sorry, I think Laura had to give me the power to unmute.
Yes, well, we can hear you.
Okay, so sorry, the question is on the reference coordinate systems or time?
Both. You had comments on both of them, but I don't know if everyone caught them. And I thought just a moment on what's going on there would be very useful and a complement to what Scott was telling us.
Okay, so what we've discovered is that for celestial bodies like the moon, NASA has already sent a number of spacecraft over the years, and we have established geodetic coordinate systems. We have established gravity models for some of the major objects like the moon and Mars. But the models that we have are the result of typically a single sensor on a single spacecraft that refines the best result that we got off of some previous spacecraft and sensor. And it's NASA's usual series of one-off missions and one-off sensors. There's no operational capability to sustain it. Whereas around the Earth, we have an international terrestrial reference frame, and that is actively maintained as an international standard with contributions from multiple sensors on multiple platforms provided by multiple countries, and academic organizations, with a large international process and set of entities that participate in maintaining that. In the United States, the NGA, the National Geospatial Intelligence Agency, which is a mouthful. It used to be the Defense Mapping Agency that was responsible for military map making, that originated with the Navy, that's responsible for those kinds of standards in the U.S. And they're also our U.S. representative to the international forums like the International Astronomical Union and so on. And so what we're doing for the moon is proposing an exact parallel to the Earth. The International Terrestrial Reference Frame is tied to the International Barycentric Reference Frame, which is where we measure the center of mass of the solar system from the, in the sun. So rather than having a lunar reference system that's offset from the Earth, we're proposing to have an independent lunar reference frame that's also derived directly from the barycentric reference system. And so it will be equivalent, and there will be mathematical transformations that enable you to convert from terrestrial reference frame to lunar reference frame. But it will mean that the coordinate systems will be different. One of the things that will enable us to do is when we convert from ephemeris representation using something old-fashioned like a two-line element that's specifically limited to a terrestrial-centric reference frame, is we'll be able to have an expanded definition of ephemeris that's captured in CCSDS navigation messages that will enable you to specify this is an ephemeris for an object that's in an Earth orbit. This is an ephemeris for an object in a lunar orbit, and therefore they're referring to different reference frames or coordinate systems. So that is in the process of being worked out by NASA and other U.S. government entities right now, trying to come up with a national approach before we take it to the international level. But our objective is, everybody agrees what we want out of it is an international set of standards that are operationally maintained. And that means it probably won't be done by NASA. It'll probably be done by some other U.S. government entity.
So, Jim, it's Vint. Does this mean, for example, that that was interesting. A spacecraft that takes off from Earth on its way to the moon might have to switch reference frames somewhere part of the way along the journey?
Yes.
Wow, that's fascinating. Okay.
Yeah. What we do right now is we use two-line elements as one method of representing ephemeris, and it's okay for an Earth orbit. But if you're trying to use a Lagrange point, say a ballistic trajectory to the moon, your two-line element representation of ephemeris will break down badly long before you get to the moon. So, we literally have to use a different representation for ephemeris. And that means people who are stuck using two-line elements and software that uses two-line elements and the terrestrial coordinate system are going to need new software along with updated message format.
Not surprised.
Yeah, I wanted to foot stomp that point. This is one of the reasons why we're looking at changing space traffic management over to a number of different commercial systems that are disjunct from the legacy systems that the 18th Space Control Squadron has been using, because the two-line element stuff goes back to the time of Hollow Earth punch cards, and the propagator models that they used back then are still tied to that. Really unsatisfactory for longer term. So if we want to have sensible space traffic management in and around the moon and so forth, we're going to need to go the direction away from two-line element stuff, as the commercial industry is already wanting to do, because we simply can't upgrade the legacy systems the way you might think. It is a break.
This is fascinating.
The same thing applies to time. So just as we have international time standards like UTC for the Earth, but they're based on a terrestrial model. And if you're in Earth orbit, you're on a slightly offset time because of the relativistic effect of your orbital velocity. So relativistic corrections are factored into GPS as a result. If we're going to have a lunar navigation service that broadcasts lunar time, it will have to do the same thing. And the moon's gravity model is a whole lot lumpier than the Earth's gravity model, so it'll be a bit more dynamic and deal with a lot more perturbations than the relativistic corrections on GPS. But functionally, it will do the same thing.
This
I
is,
would sort of also the good news is, Ben, you can correct, others can correct me, but I don't see that bundled protocol per se requires a lot of really precise time, but the rest of the networks that this thing might have to talk to will need precise time and navigation. But I think strictly speaking, there's not like some standard we have to meet for BP to work.
well, wait, that's actually, that may not be the case, because we
Okay.
have to be able to know when and where to point antennas, for example. And,
Right.
and so, and depending on the slew rates of the various components of the system, that the precision may turn out to be quite important. We also have to know when to start transmitting in order to know when it's likely to show up at the other end and be picked up, as opposed to missed by the moving
Right.
spacecraft.
And then in order to have a lunar time standard, we will likely have to place atomic clocks on the moon's surface. And so we've already started discussions with ESA and JAXA that if NASA, ESA, JAXA each put an atomic clock on the moon, then we would have the beginnings of an ensemble time, the same way that we represent international time in the terrestrial frame. And then it would have to be the source of a lunar coordinated time. I used LTC in my comment as the acronym equivalent. But that would have to be broadcast, and then everything else would have its own local time relative to LTC with some appropriate offset for its speed and altitude and whatnot.
I think that, Jim, I want to assign you a writing responsibility. I want a 3-page essay on this topic, and I want the title of the essay is, "What time is it? It takes a village to answer that question." All right, we're just coming up on 5:55 my time, speaking of time. And I think we need to start to wrap up. There, I'm sure, are other questions, but what I would suggest is that you accumulate those and send them. Scott, are you willing to accept questions from the folks who participated?
Oh, sure. And like I say, I'm the non-technical guy here, but if you want to ask philosophical kinds of things and where things are going, I'm happy to opine on that. And happy to do so.
So can we put your email address in the chat?
And the email address in chat, believe it or not,
there we go. It's space1, I love this, at gwu.edu. So this is wonderful. You really stimulated a lot of discussion and a lot of thinking. I wonder if I could trouble you to bring the slides back up again. I have just a couple of final remarks to make before we close this really wonderful webinar.
And let me bring here. It should be coming up.
Skip down.
And let's just simply skip to the end.
There we go. Okay, so just to let everybody know that this is part of our IPNSIG Academy, and you've just gotten Academy lesson number 11 from Scott Pace. The next one is coming up is an IPNSIG workshop on architecture and governance, and that will be on April 5th. So we look forward to seeing many of you at that point. If you'll go to the next slide. We just would like to invite people who are not yet members of IPNSIG to join us. It doesn't cost you anything. We are scattered all around the world almost uniformly, which is quite striking considering most of the other chapters are less so. Of course, as time goes on, we hope that the Martian and Moon membership will increase as well. If we go to the next slide, there's just a little warning that we're going to send you a survey, or alternatively, if you happen to have your mobile with you, you can take a picture of the QR code there and respond to a survey asking how do we make this better. If we did something well, as Scott just did, please send bouquets. But if you're unhappy about it, send a brickbat and we'll try to respond to that. But I thank you, especially Scott, for taking us through what is a truly fascinating journey that will only get more interesting as time goes on. And to the rest of you, thank you for joining us. I will say at this hour as opposed to this evening. We look forward to continued interactions. And as they say, see you on the net. Good night, everyone.